Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And as promised, we're going to be talking about something called the Isallobaric wind. And we're going to try to make you care about what the Isallobaric wind is before this video is over. And if at the end of the video I haven't made you care, then I have failed in my mission. But I'm still going to attempt. So here we go. And let's do a little bit of review first because we need to sort of set the stage for this explanation. So number 1, the observed barometric pressure at a given weather station is what we call reduced to sea level in order to see where the weather systems are located. Now, we all know that the pressure decreases as you go up because there's less air above you, okay? So if all we did was use the pressures at all the stations around the world, all the lows would be over the mountains and all the highs would be over the ocean. Well, we're not interested in a topographic map of the world in this case. We want a weather map. We want to know where the weather systems are. So we standardize it by saying, okay, what would the pressure be if this station was at sea level? Okay, and then we can actually see where the highs and lows are located. Now, gradient is a scientific term, another word for difference. So the pressure gradient is the difference in pressure over a given distance, okay? So it's just a scientific term that means difference. The pressure gradient force is what drives the wind. The stronger the gradient, or the bigger the difference in pressure over a given distance, the stronger the wind is going to blow. Isobars are lines of equal pressure, okay? Iso means equal and bar refers to barometric pressure. So it's like playing a game of connect the dots, okay? You find all the places that have the same air pressure and you draw a line through all of them, okay? And that is an isobar. If the pressure gradient is strong, in other words, the difference is large in pressure over a given distance, then the isobars are going to be tightly packed and the wind is going to be strong. If, however, the pressure gradient is weak, there may only be 1 or 2 isobars over a given distance, and the wind will be weaker as a result of that. So here is today's weather map at 1 p.m. with the isobars drawn in. And actually, it's sort of interesting here before we move on with the explanation. You see how the isobars down here are sort of bent over southeast Virginia and North Carolina and down here into Georgia. Well, this is a warm front, and the isobars tend to kink or bend right along cold and warm fronts. And this is a warm front that allowed temperatures to get up close to 70 to the south and east of Raleigh today, while it stayed in the 40s back around Greensboro, okay? So you'll often see this pattern in what we call a cold air damming situation. We have an area of low pressure near the Michigan-Indiana border, and then you can see all these isobars packed together in here, and so you would expect there to be a fair amount of wind in that area because we've got a big difference in pressure from here to here, lots of isobars, therefore lots of wind. However, back here, and I probably didn't make this circle small enough because over here we have quite a few isobars, but near this area of high pressure in South Dakota, we don't have very many isobars at all. So the difference in pressure from let's see, from here to here is not that great, and so the pressure gradient force is going to be weak, and therefore the wind is going to be weak. Okay, so let's add features one by one to our hypothetical weather map here. So we're going to start off with an area of low pressure, and we're going to put the attending cold fronts and warm fronts associated with that low, okay? And then we're going to draw in isobars, which are lines of equal pressure. And again, notice how the isobars kink or bend at the various frontal locations. And notice that there is a fairly strong pressure gradient back in here. In fact, really here, here, and to some extent here, there's a fairly strong pressure gradient. But one more thing that you can add to this map is what we call an isalobar, which is a line of equal pressure change. So usually when you look at a weather map, you'll not only see the observed pressure at that station, but you'll see how much it has changed in the last 3 hours, okay? So these are isolobars representing pressure rises behind this area of low pressure. Let's assume the low is moving from southwest to northeast. So as it moves on by, these areas get big pressure rises, And in advance of the low, we get big pressure falls. And when you have a couplet like this, where you have strong pressure rises very close to strong pressure falls, the wind accelerates from the pressure rise center to the pressure fall center, which would basically be from here up to here. So the wind in between these two areas is not purely going to be a function of the pressure gradient, which is dictated by the isobars, or represented by the isobars. It also is going to be added to by this gradient of pressure changes, okay? So whenever you see a big pressure rise center, not too far away from a big pressure fall center, you're going to get some really strong and occasionally gusty winds in between those two areas, and the wind is going to be even stronger than what the pressure gradient or the isobar packing would suggest. Okay, does that make sense? So that is the Isallobaric wind, the wind that accelerates from a pressure rise center to a pressure fall center, and it makes the wind even stronger than it would be with whatever the pressure gradient or the packing of the isobars would suggest. All right, that is bonus weather video number 1 for this week. There are your credits. And we'll have another bonus weather video for you coming up tomorrow. I have no idea what the subject matter will be yet, but I'll come up with something. And the next daily weather update will be coming up tomorrow as well. So you all have a great Tuesday evening, and stay safe, stay dry, and we'll talk to you again tomorrow. See you later, everybody.